All right, guys, so today we're tackling the question of what is matter, okay? If you've ever looked up on the internet or a textbook or something like that, the definition of chemistry, it says chemistry is the study of matter. So if chemistry is defined as being the study of this thing, it's pretty important that we understand what this thing really is, okay? So today we're just doing a graphic organizer about this. We're going to learn some new vocab. We're going to learn how to classify some different types of matter and stuff like that. So you can just kind of do this in your own format, paper, online, whatever. So when you think of matter, there are lots of different things that you could think of, like my table in front of me is matter. Anything that I were to use in an experiment, like a chemical or a substance, is matter. The air that I breathe is matter. We ourselves are matter, okay? Matter is defined as anything that has mass, right? And mass is like you can weigh it on a scale, right? It's pretty much like weight, and takes up space. And if something takes up space, in chemistry we would call that it has volume. So sometimes you might see the definition of matter as anything that has mass and volume, okay? So this right here is our central idea. In chemistry, that's what we're studying, is everything that has mass and volume takes up space, okay? So when you think of matter, you might say, well, I don't know necessarily what matter was, but I do know that there are states of matter, in which case you would be absolutely correct. How many states of matter are there? There are 3, okay? 3 main ones that we talk about. For any of you cool kids out there that know that there's technically a 4th one, we never, ever worry about that while we're here in chemistry, so I'm not going to talk about that right now. We're just going to stick to the 3. But they are solid, liquid, and gas. So a solid, a liquid, and a gas, okay? And now we're going to break each of these down. So when you think of a solid, I want you to think about the shape and the volume of that solid, okay? Is the shape of a solid fixed? Is it going to change? Is it constantly changing its shape? No. If I have a table, it's going to look like a table unless I really take a chainsaw to it or something like that, right? It's hard to change its shape. And it's not just changing shapes on its own, okay? So solids are things that we say have definite shape. And then if I were to ask you about its volume, what would you say? Is there a way that we can change the volume of a solid? Or is it going to spontaneously change volumes on its own? No. Okay, so this is something that would also have definite volume. If you think of anything that is a solid, like a table, it's going to take up the same amount of space no matter what. Like I could take a chainsaw to it, like we were saying, and hack it into a bunch of pieces, but those pieces would still take up the same amount of space, okay? So this kind of rounds out our idea of what a solid is. A liquid, though, is a little bit different, of course. So if I were to ask you about the shape and the volume of a liquid, what would you think of? Do liquids have a specific shape? Well, the answer to that is no, they don't, okay? Like if you think of our most basic liquid, like water, right? You could have your water in a glass and it would take the shape of that glass, right? But if you poured that water out onto the floor, would it still be in that same shape? No, okay? So liquids take the shape of their container, which means that their shape is indefinite. And what about its volume? If I have that same glass of water, that water is going to take up a certain amount of space. If I pour that water onto the ground, does it still take up that same amount of space? Yeah, it does. So it has definite volume. Cool. So now gas. So gases, think about their shape, think about their volume, make a prediction in your head. Gases, do they have a defined shape? Absolutely not. If I have a sample of oxygen gas and I have that in a container, it's going to take the shape of that container, but I could put it into another, like jar or canister or something, some other container for it, and it would take its shape too. What about its volume, though? This is a little bit harder to think about. Can I have a sample of gas, the same sample, but at two different volumes? And the answer to that is yes, you can. So it's going to have indefinite volume as well. So let's say you have a big canister and a small canister, okay? And let's say you start with a big canister of the gas and you want to put that gas into the smaller canister. Can you make it all fit? Absolutely, yes you can. Gas has an indefinite volume. It doesn't always take up the same amount of space. But if you're familiar with kind of how gases work, in that process of kind of condensing and pressing all of that gas into that smaller container, it's just going to be under higher pressure, okay? And that relationship between pressure and volume we get into a lot later in the year, but it's still very important. Okay, so after we talk about our states of matter, it's worth talking about two other very important distinctions about matter, and that is these things that we call mixtures and the things that we call pure substances. Okay? Now, you're not here to tell me which one you want to talk about first, but I want you to kind of think in your head, well, what's the difference between something that's a mixture and something that is a pure substance? And I would imagine that most of you guys are saying, well, a mixture is things that are mixed. Right. You're absolutely right, but how do we say that without using the word mix in there? And how do we say pure substance without saying it's pure? Okay? So every substance is one of these two things. It's either a mixture or it is a pure substance. It can't be both at the same time. So that's why the distinction is really important. And since they do kind of go hand in hand like that, we see that their definitions are kind of opposite of each other. We say that a mixture is something that has variable composition. And composition is just kind of like what makes it up, right? So that means it's made up of more than one thing, okay? It has more than one thing coming together to make it what it is. And a pure substance is something that has the same composition. Okay, everything in it is made of the exact same thing. It has the same composition throughout. Okay, so we can take this down even further, because not only is everything either a mixture or a pure substance, but there are two different types of mixtures and two different types of pure substances. Now, normally I make people guess what the two different types of mixtures are, because I know that you've heard these words before. I can't make you do that right now, but you can think about it. They both start with the letter H. They just have different prefixes out in front. So you can say that a mixture is homogeneous, or a mixture is heterogeneous. Okay? And some people, instead of saying homogeneous, say homogeneous. I don't naturally say it that way, but if you ever hear it on a video or something, there's two different kind of accepted ways to pronounce it. Homogeneous means that the composition of the mixture is the same throughout. So if I were to take a sample of a mixture, no matter how big the sample is, no matter how small the sample is, and if I took it from any different part of that mixture, it will always be the same composition of two or more things, okay? I can't take a sample from one side or the other side, or take a big sample versus a small sample and they be different. It is 100% the same throughout, or as close to 100% as we can be. So when we're talking about a homogeneous mixture, we're typically talking about in chemistry what we call solutions. Okay, so an example of a solution would be something like, and of course this is also an example of a homogeneous mixture.
You are currently the only person in this conference.
Sorry about that. It would be something like Kool-Aid. Okay, when you take Kool-Aid, you've got sugar, you've got your Kool-Aid flavoring packet, and you're putting it in the water, right? You're mixing it all together. So those things are still present in there. It's still a mixture. But if you take a sample of Kool-Aid, as long as it's well mixed, anywhere from the mixture, it should always be the same. So it would be a homogeneous mixture. Another classic homogeneous mixture that people don't usually think about is the air. Okay? It is a mixture of gases, but it's a mixture all the same, right? You know, the air is made up of nitrogen, it's made up of oxygen, and I'm sure in middle school or elementary school you had to memorize those percentages, and you know, it's less than 1% of blank, blank, blank. But do you actually see those things? No, but you know that it's there. And if you were to take a sample from anywhere, thinking on like a big scheme of things, obviously, like the world as a whole, it should be the same, okay?